So what is activated complex or transition state? So in this, the rate law is defined as R equal to concentration of activated complex and the frequency of complex converted into product. Frequency of complex bond rupture. At what frequency the activated complex converted into product? This is our rate for bimolecular collision. So we should take that A plus B first to form the activated complex, then this changes into product. Two step. First, what is forming? A transition state. Then it is converted into product. Is that transition state? So the hashtag use பண்ற காரணம் transition state is not intermediate. Okay? X hashtag. So the first step should be reversible formation. And the unstable may reverse into which one? Reactant also. Tell me K equilibrium. Other K equilibrium. Now I will tell K hashtag, which will be equal to, tell me, X hashtag. So I want to find first concentration. Okay. A B. X hashtag equal to what? K hashtag A into B. A into B. Clear not? Now we got the concentration of activated complex. Now frequency at which complex converted into product. Whenever the activated weak bonds will be there in transition state. New bond form, old bond break. So what is happening? The vibrational converted into which one? Translation. So H nu we can equate with KT. H nu vibration. Vibration number bond break. Initial form are KT, Boltzmann constant. Pudu bond. This is rendu equal. When it is changing into H nu is gaining from the reactant and bond break ஆகும்போது H nu. KT is gaining from the reactant. KT is gaining from the reactant. That much energy. So from this nu equal to KT by H. K is the Boltzmann constant, which is R by Na TH. So this is the nu. This you write here. Appa your rate will become X. What will be? Sorry. K hashtag AB RT by NaH. RT NaH. Okay, RT NaH. Now, this you are going to relate with which one? Your original rate law, K. So from this, the original rate constant K2 equal to what will be? K hash RT by NaH. Okay, then K2. Now this K hash we can get from thermodynamics. Thermodynamics, we know delta G hash naught equal to delta H hash naught minus T delta S hash naught. So from this, we also know that delta G hash naught equal to minus RT ln K hash naught. Now tell me, K hash naught is another e power minus delta G naught hashtag by what will be RT. Correct, Amma? So So this can be written as K naught hashtag to e power minus delta H naught minus T delta S naught by RT. Correct or not? Which will be equal to e power T delta S naught by R into e power minus delta H naught by what will be RT. எழுதலாமா சார்? split பண்ணி எழுதிக்கலாமா? So this is what case. Can I எழுதாம எழுதக்கூடாதா? Del T வரக்கூடாது இல்லையா? delta H naught. Like this we can write. So what is K naught K என்ன relationship அப்படின்னு பார்த்தீங்கன்னா K naught hashtag equal to K hashtag into C. C naught is molar concentration. Can I agree on the Kp case in relation படிச்சிருக்கோம். Real thermodynamic constant இருக்கும் actual என்ன Kp into some activity will be equal to thermodynamic constant K. Real thermodynamic constant no unit. Kp case is unit. At 1 unit molar it will be there. So for this equation K2 க்கு பதிலா you relate K hash ங்கிறது இந்த மாதிரி வந்துச்சு. சொல்லுங்க. K2 equal to K hash. What is K hash? K naught by C. அப்ப you can write RT by NaHC naught e power delta S naught hash by R e power minus delta H naught by RT. Can I get it? இதான் வந்து we are equating with AA e power minus EA by RT. Similar form. Arrhenius equation. இப்போ சில क्वेश्चन பேஸ் பண்ணி கேட்பாங்க. When rate of the reaction will be more. Rate of reaction will increase பண்ணும். Of course catalyst will decrease. When there is more அது வந்து the relationship between real thermodynamic constant and based on concentration. Real thermodynamic constant no unit. When 1 molar concentration it will come. C is unit molar concentration. When 1 unit molar concentration, your K double dash will be, there is K hashtag will be K naught. When C naught is 1, both are equal. If different means it's related like this. Molarity. Okay. Not for 1 molar, that not but different concentrations is so related. K naught is delta G naught is per mole we write it. Standard free energy is 1 mole product. For any mole when 1 mole no difference. But different moles yes there is a difference. Got it? Chalo kelo. Wait. When reaction will be more, see, when there is a more disorder in your transition state, you have 2 points. When and all rate of the reaction will be phosphate objective, multiple curricular, numerical. When delta S naught by R is great. What is delta S naught hashtag? Entropy. It is disorderness of transition state. Transition state more disorder. Then it will be what? Shape on the irregular. Then it will be rate will be. Then minus delta H by RT. Energy will be what? Less transition state. If translate more energy in delta H. This is a limiting factor. Minus e power minus. But delta H on the come here. Energy of the transition. So energy of the transition state should be low, but disorderness should be what? Disorderness should be what? Very, very high. So look at the disorderness. So disorderness high na enna artham? Reactant bonds on break action. So mari haphazard product also started to form. Pentavalent, SN2 reaction la pentavalent. The transition state should be more disorder for successful speed of the reaction. So these are the controlling factors. So this is, what is this factor? This factor is what? Frequency at which complex converted into product. The frequency. Complex converted into product. Okay. But this is overall are you getting it or not? So this is again brought into Arrhenius format. K2 equal to A, this factor. So e power minus EA by RT. Got it? EA ko delta H more suit. EA can shoot, the delta H will shoot, activation H. But delta S naught by R is the additional factor. And the steric factor e power pollution frequency steric factor, which is a controlling additional factor. Here which is a factor delta S naught hash. The orientation, that is more disordered manner it should be. So when rate of the reaction will be faster if I give the condition. When rate of the reaction will be very fast. Lesser activation, true or false will tell. More activation energy. That means what you can say? False. Obvious reaction is. Okay. More free energy of activation. When more free energy of activation, what about the rate? False. False. Free energy, that is the difference still. Okay. More entropy of activation. When more entropy of activation is the reaction will be used. Okay. By using catalyst, yes, we can actually. Catalyst is positive or negative on catalyst. Negative na mention catalyst na it's understood that it's for accelerating. Okay. Clear not? By increasing temperature, yes, we can change. Increase temperature, increases which one? More molecule gain activation energy or more. Okay. Then another one, proper orientation, making into proper orientation. More molecule proper orientation. Then also rate will come. Okay. So these are the two theories. Clear or not? இன்னைக்கு நடத்துன எதுவுமே உனக்கு தேவையில்லை for IIT JEE Advanced. But ஆனால் இதெல்லாம் தெரிஞ்சுக்கிறது எக்ஸ்ட்ரா. For that only you are coming, right? புரிஞ்சா இல்லையா? கண்ணா புரிஞ்சதா இல்லையா? So இங்க பாரு ஒன்ன மாதிரி தான் I have done, see that almost 2 hours spent for derivation everything. If you repeated practice பண்ணாதான் அங்க வந்து நிக்க முடியும் சும்மா இல்ல. So உனக்கு வந்து ஓகே நீ எப்படி கிளாஸ் அட்டெண்ட் பண்றியோ அது ரெகுலர் ஸ்மால் ஆடிட் பண்ண நினைக்கிறேன். Of course எல்லா டாபிக்கும் தேவையில்லை, ஒரு சில டாபிக்ஸ் when it comes. நீ தான் உலகத்திலே கஷ்டப்பட்டு படிக்கிற மாதிரி எல்லாரும் தூங்கிட்டு இருக்காங்க, எல்லாரும் நம்ம தான் ரொம்ப கஷ்டப்படுறோம் அப்படின்னு நினைக்கிறாங்க. Now bring the water. Have a break. So this completes chemical kinetics.